Let's look at an example of using expected value and variance rules to combine several random variables. In this scenario, suppose that the distribution for the length of a movie at a local theater is normally distributed with an average of 115 minutes and a standard deviation of 15 minutes. So let's call this M for movie. So I'm told that the average or the expected length of the movie is 115 minutes, and the standard deviation for the movie is 15 minutes. I'm also going to calculate the variance because when I'm combining several variables, I do so at the variance level and not the standard deviation level. So in this case, if I have 15 squared, this gives me a variance of 225 for the movie. Okay? And previews are, and let's use the letter P for preview, are 5 minutes on average with a standard deviation of 1.5 minutes. So let's find the variance for these previews. And to find the variance, all you do is you take the standard deviation and you square it. And this gives me 2.25 as that variance. Okay. An upcoming attraction, call it A, has two different previews and a movie. What is the expected value and standard deviation for A? So in these scenarios where you're told averages and standard deviations to begin with, and it wants you to combine them, you have to be really careful with the letter setup before trying to use any of these rules. And I will explain what these rules are. So here's my big tip or strategy for you. The number of letters is equal to the number of events. So for example, there are two previews and a movie. So I should see 3 letters showing up. 2 of the letters for the preview, 1 of the letters for the movie. So for the setup, A is going to be the movie and a first preview and a second preview. If you're struggling to come up with these combinations, I would encourage you to think about putting subscripts down. So first preview, second preview. This is not the same thing as the movie plus 2p, because this would mean that there was a single preview, but it would be twice as long as normal. So each letter represents its own distinct preview. These are normal size previews, and I have 2 of them. It's not like some Mondo ad that I have at the start. So make sure I'm matching the number of letters. So I'm asked to find both the expected value and the standard deviation. Let's start with the expected value, because I think that's the easier of the 2 sets of rules. And my strategy for you here when you're dealing with expected values is just plug in your numbers. Here's what I mean by that. If I want to know the expected length of the movie and the 2 previews, I'm going to take the expected length of the movie, 115, plus the preview, 5, plus the preview, 5. And when I do this, I get 115 plus 10. I have 125 minutes is what I'm expecting for this upcoming attraction. This problem also asked me to find the standard deviation for A. In order to find the standard deviation of A, you have to find the variance first. So I'm going to look at the variance of A, which is the same thing as the variance of the movie and the first preview and the second preview. Now, the way that the variance works here is that if you have a multiplier, you're going to square the multiplier. And these last two rules say if you're adding a fixed number, you can ignore that fixed number. But if you're adding a variable, you need to account for that variable. A way to kind of summarize these last two rules is that the variance only deals with variables, things that actually change. So in this case, the length of the movie, the length of the first preview, the length of the second preview, these are all things that can change. So I'm going to take the spread for the movie, that's 225, plus the spread for the first preview, 225, plus the spread for the second preview, 225. I'm going to add these things together. And when I do so, I get something like 229.5. Finally, to get my standard deviation, I take the square root of the variance. And if I take the square root of 229.5, I end up getting something like 15.1493 minutes or so. Now just note, if you tried adding the standard deviations together, if you had 15 plus 1.5 plus 1.5, you'd end up getting the number of 18. So you do not add at the standard deviation level, you actually add at the variance level. Technically what's going on behind the scenes is this sort of like c squared equals a squared plus b squared. It's sort of like combining things using the Pythagorean theorem. You're not allowed to just add sides to the triangle, you have to use the Pythagorean theorem. So that's a little bit of a deep dive, but if you're wondering, well, why the heck can't I just add at the standard deviation level? It's essentially you're looking at spread, and you have to start at the squared level. I want to show you an example of the variance if I had messier numbers. So suppose I was trying to find the variance of like a movie that was 20% longer than normal, so 1.2 length of the movie. There was a triple size preview, and I had to wait 5 minutes at the start of the movie because the projector was broken. So I'm looking at something like 1.20 M plus a triple size preview plus 5 minutes. So if I'm dealing with this for the variance, I just want to show you how these rules are working. I'm only going to consider the things that have letters next to them. So 1.2 M, that has a letter, so that will have spread. 3P, that has a letter linked to it, so that will have spread. 5, that's just a number hanging off on its own. There is no variation in that fixed number 5. That contributes nothing. Now, these have multipliers. So my other rule is if I'm pulling a number outside of the variance, I'm going to square the multiplier. So when I pull out this 1.2, that's a 1.2 squared times the variance. When I pull out this 3, this is squaring that as well. And it's really nice that it squares it because even if I have a negative number, when it pulls it out, it's going to make it positive. And variance looks at spread. It doesn't know the difference between positives and negatives. It only considers sizes of things. So here I'm going to have 1.20 squared times my variance for the movie was 225. And I have 3 squared, or 9, times the variance of the preview was 225. I'm going to type this into my calculator. And when I do so, I end up getting something like 344.25. If I wanted the standard deviation for this scenario, the standard deviation for a movie, that would be 20% longer than normal, a triple size preview, and 5 minutes of wait time. It'd be the square root of that number, and the square root of 344.25 gives me something like 18.554. Okay, I just wanted you to see one of these things with slightly messier numbers so you can get a feel for the process. But in general, this is how the variance is working. Anything with variables contribute to spread and you keep them. Any number by itself you can ignore, it doesn't vary. If you have a number next to your variable, a multiplier, you can pull it out, but you have to square it. Once you have the variance to get back down to the standard deviation, you take the square root. There are a lot of little pieces and rules and things to get used to when you're dealing with expected value and variance formulas, but given practice, this is something that you can get mastery over. I believe in you.